Many of you know this, but I'm going to make sure that we're all kind of on the same page, so to speak. When we look at the energy mix that's within the United States, we're all of the above sort of approach to what that portfolio looks like. And when you look at it more closely, you're seeing that nuclear energy in particular is about 19%. Globally, it's about 10. And then if you look at each of the various states, it ebbs and flows from 0 to as high as 56% for South Carolina, right? And then when you take a look at your mix, but now looking at low carbon emissions, we jump to kind of the top, right, at 47% overall. So it is a key component to our portfolio and how we do everything that we do, whether we're looking at electricity for our home, for our residences, or we're looking at our various industries. And there are 94 of these reactors that are in 28 states that are producing the power that we use within the United States. When we look at what the fuel cycle looks like, right, in this area, it's key to the uranium fuel cycle, and then we take that product from uranium fuel cycle to start the nuclear fuel cycle. If we were to go outside anywhere in the United States, we'll see uranium in the soil mix at about 0.07%. We need to enrich it to about 5% for our 5 to 6% for our commercial reactors, the nuclear power reactors. So our fuel for the light water reactors here in the United States is uranium. We're enriching it. We're making it into a pellet, and it's about the top part of your pinky, or a gummy bear, so to speak, right? And then we're taking those pellets and we're putting them into our fuel rods. And then a series of those fuel rods are making our fuel assembly. And that fuel assembly, right, we've got a series of those that are making our core. And then it sits within that reactor vessel. We are splitting the atom, and we're using water as our moderator for the fission reaction, but we're also utilizing and taking that heat to move through a system for the creation of electricity that we put onto our grid system. Now, every 18 to 24 months, as we're doing that, we do an outage. And we're shuffling fuel, and then we're taking out some of those fuel assemblies. And they sit in spent fuel pools on site. And then after that, usually around 7 years or so, we're moving them into dry cask storage facilities or canisters at various facilities. The map here is showing you where we have the license and the operating IFC, right? The Independent Spent Fuel Storage Installations by state. And there are about 70 plus sites. They're decentralized. And the idea that has been floated, right, is that we should centralize them in some way, shape, or form. And that's where we come in helping the Department of Energy get some feedback on that. So this is what the IFC sites look like, the canisters, and they sit on a concrete slab. You can actually get public tours of these as well. So this is a busy side. So just to say that, we started the industry back in the 40s and 50s, and by the time you get to the 70s, we're looking at having a policy around storage of our spent fuel. As we go through, we're also looking at those centralized sites, and there were 7 that we were considering. Yucca Mountain rose to the top, and then we started to build on that particular site in Nevada. That was halted, and we're kind of following what I mentioned earlier, where it's in spent fuel pools, and then they go to the dry canisters, cask canisters on site. Then around the early 2010s, we started to look at consent-based siting or collaboration-based siting. There are other nations in the world that have followed this particular format, whether we're looking at the Scandinavian countries or Canada being the closest one to us. And as we continue to think through, or the Department of Energy started to continue to think through what exactly does collaboration-based look like? They decided that they would do a proposal and have awardees, of which we're one of the 12, go out and have interactions, engagements with communities. So in 2023, they awarded the 12, and we've got 2 years, so we're coming towards the end of that, to engage with individuals, collect that information, and to synthesize it and share that with the Department of Energy. So that's where we're at. This program, what it's hoping to do is to engage for broader participation, also to develop a process for how that we go about the engagement, right? And then also to help for some of the communities that have expressed interest, that are interested in knowing more about the process at hand, and to build mutual trust through that dialogue and really listening through these listening sessions and collecting that information that then we will share. We at the very beginning stages of everything, right? So this is the planning and capacity building component, that engagement, that dialogue, that discussion, those questions and answering some of those questions and collecting those sets of questions. So that's where we're at. And the hope is that then we can develop a strategy to do this a whole lot more and gather quite a bit more feedback and the questions and responses accordingly. So why Utah? You know this, right? Especially as we're introducing ourselves. This is where uranium lies, and there we do the mining, and we also do the milling, right? It was part of the World War II initiative for the Cold War as well, and we're also using uranium for electricity and other non-energy applications of the technology. So once again, today this is kind of what the flow that we're going to have today. And I'm going to hand it off to Native Nuclear, Scott in particular, to start our personal stories and personal journeys with uranium and also kind of the nuclear enterprise